We are back with our zoo example, and so far we have created an animal class, and we have the implementation for the animal in our .cpp file. We have created a driver, and we had fed the tiger, and now we are going to create a reptile. I already have some information in here for the reptile. We'll come back and look at this in a few minutes after we get our reptile kind of squared away. So in order to create a reptile, I'm going to add a .h and another .cpp file. And just remember that's a right click, and you can go ahead and add a new item. And you have to then select on whether it's a header file or a .cpp file when you add the corresponding files. So that's how I created the reptile.h, and then I came back in and created reptile.cpp. We are going to take a look at the reptile header. And the reptile header we're going to need, because a reptile is going to be a subclass of animal, we are going to pound include animal.h, and we're going to pound include IOStream. We are also going to pound include string, and then we are going to use using namespace standard. It is not, there are two schools of thought on this. Remember that you should never have the using namespace standard in a header file, and that you should always use the std : whenever you have a string then. But in order to make the code a little bit more easy to read, I'm going to go ahead and use using namespace standard here. So when I create the class reptile, we start with reptile. That's the name of the class. But because reptile is a subclass of animal, we now have this additional line of code that we put here. In order to tell the compiler that reptile is a subclass of animal, I use a colon, and public access is going to be given to me to animal when I write it this way. So now everything that's available in animal, such as the weight, the name, and the food, is going to be available to me in reptile. Then we just need to add our additional variables in a reptile. And I don't remember if I've mentioned it, but our reptile is going to have an additional class variable temperature. That's going to allow us to check the health of the reptile and to check the environment, because we need to make sure that the environment is safe for our reptile. We will also have public methods. In our public methods, we will have a constructor, and I'll come back to this in a minute. We are going to make that a parameterized constructor. We are going to have a method to change the temperature, because if the environment is not appropriate, we want to be able to change the temperature, and that's going to allow a double variable. We are going to be able to feed our reptile, and again, data type there is going to be double. We will not feed the reptile 20 pounds of food like we did the tiger. We will be able to get info, and we will be able to get the total food for the reptile. And those should be our header methods, with the exception of finishing our constructor. We're going to go back and complete our constructor, and I'll be real honest, I'm not sure where I left off. I think I made some changes in animal, and I don't know if that was recorded in the last video. So what I decided to do was the following, just to review that, is because we're using a static class variable for total food, I really don't need to include that in my constructor. And so my constructor for an animal is going to include a name and a weight. My implementation for an animal includes the name and the weight, but my static class variable is created and initialized before the class here. And so I don't need to include that in my constructor. And so that's going to affect my reptile constructor. So if I go back to reptile now to create the constructor for a reptile, I'm going to need a string for the name. I'm going to need a double for the weight. I'm going to need a double for the temperature. And I'm going to need That should be it. I need the name, the weight, and the temperature. Now, because Reptile is a subclass of an animal, and I don't want to duplicate code, I want to reuse the code I already have, I am going to call the animal constructor from my Reptile constructor. So what do I need to send to an animal constructor? It needs to match name and weight. So I'm going to send it name and weight. And then the only other variable I need to set here is temperature, and that will be assigned temp. And so the way that this constructor is going to work, I am going to call the reptile or create a reptile with a name, a weight, and a temperature. And if I look at my zoo driver, you can see that I did that here. I'm creating a snake. His name is Slither. He weighs 10, and the temperature in his cage is 75.67, and that's Fahrenheit. And so when that constructor gets called, it's going to go to reptile.h, and that will then send it to the animal constructor automatically. So I don't need to do any of that behind the scenes. Now I have written this constructor right into my header file here. And so that's what we would call an inline method. The other methods I will complete in my implementation file. And I believe I already have those completed. So let me look over here at reptile.cpp. And I went ahead and typed this up ahead of time, but let's just talk through it quick. To change a temperature, well, two things. Number one, I used pound pragma once, and I need to pound include reptile.h. I don't need to pound include animal.h because when that's already done. Because when a reptile is created back here, and I tell it that it's going to pound, reptile is going to pound include animal.h, that has already been done. So I don't need to repeat that. And the way that that kind of works is that all of this code here gets copied in as well as the .cpp. So you could almost think of these two as one file. And if you remember, that's how we started creating classes, is we had the header information and we had the .cpp information all in one file. So I don't need to repeat pound include animal, but I do need to tell it to look into reptile. So then everything that's attached to reptile will be also attached to this file. So change temperature is pretty straightforward. I'm just going to add the amount. Now I could change temperature, could go positive or negative. So if I add a negative, it'll decrease the temperature. I'm going to, when I feed the animal, it's not going to be any different than when I fed my tiger. And so if you look, I am using the superclass animal feed method. In order to access a superclass method, you have to preface it with the superclass and then the scope resolution operator, and that's the colon. Get info is a little bit different. I'm going to use the animal get info method, but I want to add a little bit of additional information because this is a reptile. I don't check the animal's temperature, but I do check the reptile's temperature. And so this is going to call the superclass animal get info, and then it will add in the temperature get info. And last but not least, the get info for the total food is exactly the same as the animal class. So I'm just going to use the superclass method. But to tell it I'm using the superclass, I need to again say I'm going to access the animal superclass method, followed by the scope resolution operator and the get total food. If I go back and look and clean up my code and execute, we'll cross our fingers that this will run. If I look at my zoo driver, finishing up this example, I switched to the driver class, and if you see here in the driver class, I've got pound include animal.h, pound include reptile.h, and we created the tiger like we had before, and then I created a snake for my zoo, and just showing the info, get info will work for a snake, and when I run this, you are going to see that the snake has additional information. It adds in the same methods from the animal class, but it also adds in the current temperature. And so right here you're seeing it call the parent class method, and here it's calling the child class method. And then we change the temperature, and you can see that the temperature changed for the snake, and the total food consumed for the day is 41, which is a total of the tiger's food and the snake's food. And that should kind of wrap up this example for creating a superclass and a subclass. Our next examples will actually take the animal class and make it a more abstract class. And that should be it for now.